So that being said, Caitlin and Jason, I will let you guys take it, maybe start with introduce yourselves and dive into the presentation.
Awesome. Thank you so much, Karen, for that introduction. So my name is Caitlin. I'm the communications manager at SMT. I'm going to be presenting to you today and helping you all understand the wonderful world of roof electronic leak detection. And then we also have Jason on the call. He is our president and co-founder of SMT. When we get to the question and answers part, we're going to be both talking about just more technical aspects, things like that. And of course, if you have questions for me during the presentation, I'm going to try my best to keep an eye on the chat. So just drop them in there when you think of them. So I'm just going to share my screen. Awesome. Can everyone see that all right? Perfect. So I already just gave us a little introduction, but of course you can see our beautiful faces right there. This is SMT. And today, before we get into too much about our monitoring solutions, I'm just going to briefly talk about what we do as a company and who we are. So we're structure monitoring technology, and we've been providing electronic leak detection and building envelope monitoring solutions to roofers, general contractors, architects, and engineers for over 17 years. During that time, we have been able to reduce the frequency of unnecessary roof repairs by providing quality assurance throughout the construction and restoration process. We've been involved with hundreds of projects, ranging from simple wood frame homes to glass and steel skyscrapers, shopping centers, heritage buildings, art museums, data centers, and national research labs. We're primarily roof leak detection, but we also have some other solutions to monitor other parts of the building, like walls and flood monitoring, something that I'm not really going to get into too much today, but we can talk about at the end if you're interested. The two top photos on the screen are two signature projects that we have been involved in, and I'm going to be making some references to these projects throughout my presentation. The one on the left is the New York City Jacob K. Javits Center, which we put our fully automated leak detection system into that project's expansion and scanned the roof for quality assurance. And on the right, Vancouver's Oak Ridge redevelopment, so Vancouver, British Columbia, Canada. It's set to be one of the largest redevelopments in Vancouver's history and is currently also going to be SMT's largest project. The reason why I'm talking about these two specific projects are they have something in common. And what that is their roof provides other purposes other than just protecting the building underneath it. So when I meet people in life and they ask me what I do for a living and I have to explain to them, most of the time they have no idea what leak detection is. So in order for them to get it, I have to explain how roofs nowadays serve many more purposes than what they used to. So for you as an example, I live in an apartment that is situated in a city on a very busy street. I don't have any parks or any sort of green space that is close to me in a walkable manner where I can enjoy the outdoors. But in my building, we do have a rooftop patio and garden space. It's where we're able to barbecue. It's where dogs in our building can go to relieve themselves. And we also host community events there. That space is very much needed for myself and for all the other residents that live in the building to be able to see some greenery and also have some space for community building. And it's becoming more and more common to turn roofs into these multi-use spaces. So if we're going back to the projects I previously just talked about, Oak Ridge is a mixed-use project that incorporates 9 acres of city park space situated on top of retail and residential spaces. It's going to be used by almost 20,000 residents that are going to be in the area, and the open rooftop space can double for a music venue. So we have this beautiful park space that's going to be used for kids' sports, community building, anything like that, runners. And then we also have the opportunity to generate revenue from this space by hosting markets and music festivals and things like that. If we're talking about green roofs, there's more than just one type. There's also, outside of just a patio or a park space, we have rooftop gardens. A good example of that is the Javits Center. So if you look here on the right-hand side, that is a picture of the rooftop farm that is on the Javits Center that will produce food that is going to be used in the millions of meals served at the convention center. So if you want to talk about the 100-mile diet, you can't quite get better than that, being able to just go upstairs and get your food for the meals that are being served. And of course, with that, there's tons of benefits. Not only is it a very cool thing to say that you can do, it's saving the effort of having to ship products in from other places around the country. And for produce, it's just best when it's fresh. And then another feature popping up more and more is solar panels on roofs. So this is something I'm going to touch on a little bit more further into my presentation. But of course, the many benefits to that is the building is now being provided power from an otherwise unused space. All of these roofs are innovative and provide a lot of benefits. But the thing is, finding a leak in these types of roofs are going to be proving a challenge and costly. When you have such high value assets like solar panels, green roof elements on a roof, if you don't know where that leak is, you have to rip all that up in order to find it. That's going to end up costing you a lot of money, and it's going to waste a lot of materials. So with that, we think that it's critical to know about changes in moisture levels well before they become an active leak. And we achieve this by monitoring. Before I get into a little bit about how we monitor, we're just going to talk a little bit about what we see on site and kind of how we get to the point of a leaking roof. So we see a lot of types of roofs as they're being built. And one of the many reasons why they start leaking is because of damage that is in the membrane from construction. The unavoidable problem is with any project, parts of the building are being built while other parts of the building are unfinished. So what I mean by that is roofers, when they go in and they build the roof, oftentimes they have to stop midway through in order for other work to be completed on a different side. The problem with that is the roofer can't be on site while that roof is left exposed. They're not able to be there to look to make sure that no one's coming in and damaging their membrane. And so what ends up happening is, generally speaking, roofers build very good roofs for the most part, and membrane manufacturers put out good products. The issue is with other tradespeople not having the adequate education to know that they have to be careful around that roof membrane. So here's some photos of some things we've seen on site. Damage that can range from holes to cut marks to thin membrane in certain parts. You're trying to imagine a large-scale commercial project that could have hundreds of thousands of square feet of roof. Going back and finding these damages just by visual inspection is going to be difficult. So just going back to damage that we see. So as I was saying, it most of the time comes from other tradespeople who may not be educated on the importance of keeping the membrane intact. We've seen forming nails left behind. We've seen metal debris falling on the newly applied liquid membrane and drying into it. We've seen the new membrane being used for material storage. And we've even seen tradespeople damage the membrane by not being diligent with their tools. On one of the photos you can see by the caption, it was accidental damage made by a reciprocating saw. Another important thing to note is while all of these photos that I'm showing you here today on the presentation make for very good photos for marketing purposes, often this damage is much, much smaller and you can't actually see it by doing a visual inspection. With that damage, it's going to stay there and of course turn into a leak. The first way we try and prevent leaks is by educating the public on what happens on site and how it can lead to a leak. That's why we want to get involved with you guys and with Rivers Coffee Shop as well to spread the word on what happens and what tools we have available today to mitigate that risk. So going into those tools, the best way to protect these roofs is using FutureCast, a non-destructive automated monitoring leak detection system that is made up of sensors embedded right into the roof assembly that monitors for signs of moisture. This permanently installed automated system will log data and will generate a status report of the roof. The data is logged by a data logger, which sends the information to the cloud to be compiled into a report. It will narrow down the area in the roof where the water is coming from, which will allow the roofer or the building owner to make targeted repairs. FutureCast can be put in a passive state. So what that means is an SMT technician is called out to the site to take readings on a scheduled basis. Depending on the project, it could be once a season, once a year, depending. And from there, we will generate a report and give it to the client on an update of their roof health. If you see on the picture here, that little blue box, that represents a junction box, which hosts the Building Intelligence Gateway, or BIG, a compact computer designed to continually gather sensor data. When FutureCast is kept in a passive system, an SMT technician comes to the site with the BIG they bring with them, and that's when they take readings to give to the building owner or to the building manager. The most value to FutureCast, though, is by having it actively monitoring all the time. That means it's constantly taking readings and generating reports as often as the customer needs. By having it constantly running, we're able to get the best idea of what the normal range for that roof is. And when a leak event happens, or if there's a change, we can send a notification right away to their email. So for the complete package solution, we have some add-ons to FutureCast. We have both AR and VR capabilities. So I'm going to start with AR. I'm going to just show you guys a really quick video here. It has some sound showing some of our AR. Let me know if you can't hear it.
I don't hear it.
Sorry, just a moment.
Yeah, I don't hear it as well.
I always have this trouble with video and PowerPoint.
You know what? I might just.
Yeah, if you just want to talk over it, or I can talk over it, Caitlin. If you
Well,
wish.
I was going to say the narration in this video is actually my voice, so I might as well just narrate it. So what you can see here is an augmented reality picture that is the moisture detection strips. Sorry, I can hear the video, so it's messing me up a little bit. So you can see here the green lines are showing where the moisture detection strips are dry, and on the red lines, they're showing where it's wet. So as you can see, this is a solar roof. So going back to what I was talking about before, having to pull up these solar roofs to look for a leak is, again, going to be very costly and challenging. The idea with FutureCast and with augmented reality is we want clients to be able to see what is happening under their roof at any time without having to tear up any part of the roof. Because now imagine you're a building manager who just received an email from us letting you know that there's a problem. You can then walk up to your roof, pull out your phone, and look through the AR on your phone to see where the problem is, and you can then plan accordingly. That way we don't have to wait until we're seeing water coming from the ceiling. And in the video, like I said, we were showing the solar panels. We don't want to waste those materials. Let's save that money, right? So now I'm going to show you guys some AR capabilities. This video does not have sound, so it's just going to be a visual aid. So if we again imagine ourselves as a building owner, but in this case, we own assets in a completely geographical location, or maybe we own multiple buildings. Essentially, we're in a situation where we just don't have the ability to walk up onto our roof and check it out. We have AR. So that way the client is notified of a leak, but rather than having to go there and physically see it, they're given a status where they can view their roof at any point, anywhere that they are. So in that clip, we showed UBC Brock Commons, which is a student residency in Vancouver that we were able to work with. Now I'm going to get into a little bit about how it all works. So we install FutureCast in different roofing assemblies. conventional roof assemblies being one of them. These are the typical roofs found on large warehouses with membrane on top of layers of insulation and a roof deck below. These assemblies are meant to be dry, with the waterproof membrane protecting the entire assembly from the outside. When we monitor conventional roofs, we're looking for the presence of moisture beneath all of these layers. When we install FutureCast, we put it underneath all the layers above the roof deck. We install it in a grid made up of stainless steel moisture sensors laid out in strips. They're sensitive to the presence of moisture and are therefore triggered when water is allowed to accumulate inside the roofing assembly. So like I was talking about before, FutureCast sends a report of how much moisture is in each square of the grid. So if there is moisture, we'll be able to narrow it down to a much more isolated area. And depending on the size of the building, budget, and needs of the client, we can make this grid in different sizes, like 10 by 10 or 30 by 30. We'll be able to pick up the moisture penetrations in these areas, which is where most of the leak problems come from. When you look online on our conventional roofs, you'll be able to look at each detection strip, click down and go into detail to see what's dry and what's getting more wet. Most of the work that we do with conventional roofs are things like data centers, large retail warehouses, healthcare facilities, art galleries, the like, buildings with a lot of high value assets sitting below the roof. People think that we're here just to protect the roof. And I did talk about that earlier about how it is important to protect those roofs that have multiple uses, but it's just as important to protect the assets below it. We don't want to imagine a roof actively leaking down into a national data center or water dripping down into an operating room. With analytics, we provide maps, data, and graphs that also help track drying out processes. Let's say we found the leak, called the roofer, and they've come to repair it. We want to make sure it was adequately repaired and that we found all of the sources of the leak. With our reports, you'll be able to see the progress that is being made or not being made, depending on if the leak was repaired or not. We made it pretty easy to read, and on this graph right here, we have lines that represent the moisture detection strips. The ones that are in red in color are the ones that are detecting moisture. And of course, the ones that are green are the ones that are dry. Then we have FutureCast on inverted roof assemblies, which is quite different from FutureCast on conventional, but is by far our most common type of system. Going back to the green roofs I was talking about before, they're often on inverted roof assemblies, which have the waterproof membrane on the bottom, just on the top of the concrete deck. We put FutureCast on the top of the membrane to monitor for membrane breaches on inverted roof assemblies by using a method called electronic field vector mapping. How this works is we electrify a light layer of water on the roof to look to see how the electricity travels through the membrane. If there's no problems, the electricity should just sit on top. The membrane wants to keep water from going through it, but if there's a hole, when the water will make its way down, that's what we're sensing with FutureCast on inverted, is if the electricity is following a path of moisture down to the deck. I'm just going back to this slide again because this is FutureCast on an inverted assembly. Inverted roof systems are also installed in a grid. Again, the size of the grid kind of depends on a few different factors. So for example, on Javits Center, there's hundreds of thousands of square feet. So they opted to have a grid that can monitor large areas that will better fit their needs. How we set up the grid is by laying down electrical field tape, EFT, which will be used to electrify the roof deck in search of membrane breaches. The red star in the middle is a digistar. That is a sensor which will use the electricity provided by the EFT to point towards a leak. If the roof gets wet, digistars will work and the EFT will work together, like I said, and that they will identify where there is a path of moisture leading down to the concrete or to the steel below. So from there, these systems give us a bunch of data and that is sent to the cloud and turned into reports. Below here on this slide is an example of an inverted roof report. So on the bottom here, there's a bar that tracks participation and we track where the grid is wet. So we know whether or not there's an immediate problem. The darker the red color on this graph, the more moisture there is. So if you'll notice, there are some squares that are a little bit red, a little bit green, very red, or very green. That's going to give you an idea of which areas are the most wet and which areas need the most attention right away. Then the top one is a graph that shows us with arrows where the leak is. So that way with these, we can know where the leak is, which areas are wet, and which ones need the most action. For Futurecast, we can start collecting data as soon as there's power provided to our systems. So we can actually start tracking while the building is still being built, which is great for those fun projects with interesting roof challenges. And then from there, we'll be monitoring for the life of the building. For a lot of our projects, we'll put together a maintenance and monitoring plans for 50 years into the future. And we've had systems installed for 15 years that we are still working with. So in the interest of time, I'm just going to give a very quick brief over what else we have outside of Futurecast. So we have different leak detection solutions to meet different needs for different projects. Something I wasn't able to go into detail today was our DigiScan quality assurance service. We have a membrane scanning tool that we use on inverted roof assemblies to look for membrane breaches at the time of construction. So going in and giving the opportunity to the roofer to do some quality assurance, and then giving them that report so they can then go back and repair those damages before the roof is finished. This is a really good method of leak detection, as we're finding those breaches before the roof is even done. And then this is just a very short video of us using the DigiScan around a membrane breach to kind of just show you how it points to where the breach is. DigiScan uses a very similar method to Futurecast inverted. It's the same idea of electronic field vector mapping. Another aspect of our business as well is we are a part of a lot of research projects too. We sell our sensors and we get involved with research in order to be innovative. Research is literally in our name. So our sensors and data loggers are not just used in the field, but also in lab conditions to test new assemblies or products. And here I have a couple of examples that are all available on our website. And I have even more resources too, if you would like to be sent them after our meeting. And of course, we also have many, many more documents outside of just research. We have specs and we have deck to cloud documents that go into a lot more detail about Futurecast and DigiScan. So I think that's it for me. Thank you so much for listening to you guys. I'll open it up to some questions.
Caitlin, that was great. I see some questions in the chat. I'm really curious just to kind of hear we have Tony, I was thinking the same thing. What if a sensor fails? Do you have to tear the roofing system up? And if you could get into that would be really interesting to hear.
Yeah, for sure. I'm just going to quickly stop sharing my screen. Actually, no, I'll keep it up. I just can't see the chat at the moment.
Yeah, it's difficult in Zoom to see the chat. I can see it here, Caitlin.
Okay.
Yeah, my name's Jason. Caitlin introduced you to the system. A couple questions, one in regards to a failed sensor. So the sensors that we install and embed within the roofing system, we often call them dumb elements, as in there's no electronics like integrated circuits or what you consider electronic device that's embedded within the roof. So they're sensing elements. So the electric field tape is stainless steel, 13/16 stainless steel ribbon that's flat conductor that's placed within the roof. And then the DigiStar itself on an inverter system, since these are on the wet side of the membrane, are set up with waterproof cabling and etc. And all that comes back to a junction box where the electronics are put in. Our system is commissioned primarily right before the overburden gets put on place, so right before that drainage mat installation and green roof media goes in, and we make sure it is functioning. But there is cases where you do have a failed sensor or a sensor element that has been damaged in that process. A couple of methods. One, we have gone back and dug up the roof in discrete areas to go back and replace cut cable because of, the green roof does go through, I'll say, a metamorphosis often because you are putting in concrete elements or benches, etc., or someone's decided to put light poles on top, and you can replace the cabling. You can join the sensor in field from that application. In other cases, in a case of a damaged sensor, we will discuss with the owner in just making the grid bigger. So the way that the system goes in, we can take it from a 10-foot by 10-foot grid and now make that one area 20 by 20. So you have a little less granularity on where you're able to locate the leak from the automated system, but still remain functional. So hopefully it answers that question. It is something that we deal with on every one of our installs. So one of the other questions that came up was what voltage our system was using and US approval. The voltages that we're typically using within the automated FutureCast inverted are under 12 volts. We've been working with some systems up to 36 volts. Same thing with DigiScan when we go out and scan membranes, and it's all UL approved transformers, electronics that go into those types of systems. They're also in taking the measurement of these systems. We answer all sorts of questions, everything to deal with electrical system interference, etc. Our systems are left on for milliseconds to 2 seconds to take a reading. They're not on continuously all the time, but there are special things that should be taken into consideration, things like lightning protection, etc. But we are typically below all the other building elements like flashing, the green roof, or underneath the membrane in the case of a conventional roof. To answer Karen's question, the question is your system being included in specs for new construction? Are manufacturer's warranties affected in any way? This is a really good question, and what we are navigating is going through different approvals with different manufacturers. In certain jurisdictions, we're actually required as part of the warranty being provided, even by a roofing contract association warranty or a manufacturer's warranty, is now requiring leak detection systems. So I don't think that was the intent of that question. I think it was meant the other way, as in it would still be as a system approach. I know we have worked with most of the major brands within the industry, but there's always one or two different assemblies. You may want to look into having us approved to go with that system. We're not putting in a primer. We're not putting in a conductive layer within the roof assembly like some of our competitors are in this space. Our sensors are less than 3/4 of an inch wide, and we're not affecting the overall adhesion that a lot of the other systems with conductive primers, etc., are concerned about in wind uplift warranties, etc. Most of our work within leak detection for roofing is new construction. We do a number of government jobs on the re-warranty or on the re-roofing side. You extensively, in order to get these extensive systems installed, require you to tear up a large part of the roof in order to get them embedded. There's probably Caitlin alluded to other types of solutions that we have. We've done lots of work in existing roofs. 97% of the world's roofs have already been built. How do you maintain them long term? How do you do that? And we'll actually have a different sensor system that will go into embedding within conventional roof systems. So it's sort of probably a different topic. Forensic investigations of using sensors embedded within roof assemblies to understand what's going on. And it's a complex little issues that arise that more comes related to our building science experience from more of our wall monitoring that we're bringing over into roofing.
Thank you, guys. Are there any other questions? I'm curious, just personally, it's quite a, there's software involved, there's reports, there's got to be ongoing monitoring costs. Is that the building owner that's subscribing for the service?
Yeah, so I mean, SMT provides the hardware, the firmware, the software, and then the ongoing monitoring as well. We have a number of users that will have, like on a campus environment, 30 plus buildings that they've engaged with SMT, and we train their maintenance people to how to look at the reports, how to look at the data. And so they're on what you would call a self-serve monitoring system. Other clients, I think the one comes to mind, we're doing a biotech facility right now, and it's in new construction. And unfortunately, they're having to do sections of the roof for the third time from it being damaged. And there's a zero tolerance for any moisture within that conventional roof assembly. In that case, we're a little more engaged. The client has just said, hey, how much for us to have a project manager oversee the data as the third time of the roof's going in. And so that's more of, it's a service fee that goes along with a monitoring fee. So it ranges from, the $50 a month self-service, you go in and have a look at the data, all the way to thousands of dollars of us assigning a specific person to your project. And that's been some of the growth that we've done within that service offering.
Excellent. Any other questions for Caitlin or Jason? Their contact information is on the screen, so hopefully you jotted down their website. You can take a look. They shared all that research is on your website. Is that correct? Yeah. It'd be very interesting to dive in. And Jason and Caitlin, I met at IRE in New Orleans, I believe, last year, and they chatted with Anna, Heidi, myself, and we just thought this would be an interesting technology, kind of for the future of where we're going with leak detection on the roof. And it'd be great if there was a system for retrofitting, but other than tearing up the roof, maybe it's roof replacement time that you see that happening.
Yeah, I mean, there's twofold to that, is scanning solutions. I mean, it should possibly be another topic about roof maintenance. So we go through, is there infrared thermography available? Is there a Trimax capacitor scan in the case of a conventional roof? Is there, in the case of an inverted roof, systems that are left in place that we can scan against or get involved in investigations? Ultimately, we also put sensors in them right within the roof deck to help just determine the exact time that a leak is occurring that clients may not have recognized. If you get a notice from a property manager, last week we had a leak, and you're like, well, was it the same time that, you had a windstorm that dumped, 2 inches of water on the roof? You can start looking at exact correlation. Impact detection as a question is an interesting one. I'm most interested from some of the data that we have on ponding water. So we presented inverted roof assembly with our leak detection. One of the things that we like to know is there water down at the membrane level, just to see that our system is functional or going to have a really accurate reading that the membrane is in fact wet, and it's going to make electrical connection to a potential penetration. We presented that data alone, and somebody goes, you can tell us where there's ponded water below our green roof? And I'm like, yeah, is that something you want? And they're like, yes. Well, and so they could go after, maintenance on drain systems, or how much irrigation water was requirement, etc. Impact detection. I mean, I'm always watching and always amazed how low cost sensors become when they become part of two primary industries. One is the automotive industry, And the other one is these devices that we all carry with us now have 1,000 different sensors on them. And we always watch to go, can we take sensors that are being used within the industry, bring them to the construction industry? Because construction typically wants lower cost and more extensive sensors installed. And it takes a market to go in and bring those, say, impact detection sensors from, $100 each down into, a couple dollars each. And typically construction is not the first innovator to take those sensors, right? And put them through a mass production. So I mean, it's a good interest, and we'd love to do a pilot project on hail detection. Some of the work we've done on the research side, and we could probably do an hour presentation just on roofing research projects we've been involved with. One is to monitor differential pressure between the different layers within a conventional roof, and what data you can get out from that. So can you tell the moment right before a single ply membrane tears open? And can you tell how much fluttering it's doing during different events? And that might be one of the extensive sensors that we could deploy that would look at, is your membrane penetrated by hail? And so there's all these different discussions within the sensing world. Do we try to detect it directly, or do we try to detect it indirectly? So there's some concepts there.
Last quick question for you. Do you guys present at any of the industry conferences, IRE, Western? Do you have any slated for this year?
So we will be at IBEC in Houston. As far as an exhibitor, we're doing some projects and a lot of work within the mass timber world right now. So basically innovative structures that are going up with mass timber. We're extensively involved in that. Most of our clients are the ones that present. So at the building science and technology conferences, I was at a conference just before Christmas, 60 presentations, 8 of them had SMT technology behind the scenes. So those are the ones that we like to see, the technology being used there. We're a small section of, hey, here's the instrumentation that was used, and there's like, half a slide of reference to us, but it's really the knowledge that is coming out and helping, I'd say, a younger generation of building envelope and roofing consultants understand what's going on in going through this. And I'd say that there's an understanding on the new system side. There's an understanding on existing roofs, how to maintain them. And then ultimately, what you're trying to avoid is litigation. And we do a lot of work in forensic monitoring, and been involved in 7-year plus projects, and everyone pointing fingers at each other. Let's go get some concrete data. Let's understand what's going on. And that's somewhat separate from the presentation that Caitlin gave today, but that's fundamentally what sensors embedded within construction products will enable us to do. So.
Oh, cool stuff. Thank you, guys. Really appreciate you being here. I'm just going to share a little bit about what's coming up this spring for RT3. You guys are welcome to stay, see what we've got going on, or if you got to go, hop off. Certainly understand. I'm going to take back over the screen from you, Caitlin.
No problem.
Share my screen. Let's get rid of all this junk up here. Okay. Here we go. So there was my thank you. Any questions? We got through that part. So coming up, the Monday